This is a review of multiplying and factoring polynomials pre-assessment. So this is broken into two pieces. The first section is going to be just multiplying. So when it says find each product, we want to simplify. We have 7 times the quantity 6n plus 7. So we can't combine these two because they are unlike terms. We would always do what's inside the parentheses first, orders of operations. But since we can't simplify those two because they're unlike, we can simplify this expression by using the distributive property. 7 times 6n plus 7 times 7. We are distributing that outside term to the two inside terms. 7 times 6n gives us 42n. We multiply the constants, and then we multiply the variables. Since there's only one variable, it comes down. And then 7 times 7 is 49. So my answer would be 42n plus 49. We'll again do that with each of these distributions. You see that we have a monomial times a binomial. Monomial times a binomial, monomial times a binomial. So one term times two terms in these first couple of examples. So we're going to distribute the 2 times 2v plus 2 times 6. 2 times 2v gives me 4v, 2 times 6 is 12. 4v plus 12. Next one, we're going to distribute the 8 into each of these two terms. 8 times 5a plus 8 times 3. That gives me 40a plus 24. Now this one, number 4, notice what we're distributing has a variable. So we're going to distribute that to each of the terms still. We're going to have 3b cubed times 2b plus 3b cubed times negative 5. Don't forget that negative. So here we're going to multiply the number or the coefficient times the coefficient, which gives us 6. And now we multiply like variable with like variable, and there's an invisible 1 there. So when we multiply like bases, what do we do with their exponents? We are going to add them. So 3 plus 1. So that's 6b to the 3 plus 1. And then we have number with number, and then this variable just gets attached. So we have, 3 times negative 5 is negative 15, b to the third. So my final answer is going to be 6b to the fourth, because I added 3 plus 1, minus 15b to the third. And we can't combine these because those variables are not the same. We can multiply unlike terms, but we can't add or subtract unlike terms. Here we now have two binomials. So what we have to do is we are going to use the FOIL technique. We're going to multiply the firsts, we're going to multiply the outers, we're going to multiply the insides, and then we're going to multiply the lasts. So we have, how am I going to do that? Where am I going to do it? Let's do it here. So the first would be 4a times 5a. The outside would be 4a times 2. The insides would be 5 times 5a. And then the lasts would be 5 times 2. We get 20a squared when we multiply that. We get 8a when we multiply that. We get 25a when we multiply those two, and then plus 10. And we'll notice that there will be situations where we have our outside and inside, and they will be like terms. They are both a to the first, so we would add or combine their coefficients. So my final answer is going to be 20a squared plus 33a plus 10. That would be my answer to number 5. So we can do this. Hopefully at this point you are able to visualize. So when I see that 3n times n is going to give me 3n squared, 3n times 3 is going to give me 9n, 1 times n is going to give me n, and 1 times 3 is going to give me 3. So my answer is going to be 3n squared plus 10n plus 3. And that's pretty much how most students will do this. And you should be able to do it that, implementing that much mental math. So let's look at number 7. We get 40a squared plus 16a plus 5a plus 2 gives you 40a squared plus 21a plus 2. Let's look at this one. b times 2b gives me 2b squared. b times negative 8 is negative 8b. 5 times 2b is 10b. And 5 times negative 8 is negative 40. Why do I keep doing a? Very weird. 2b squared plus 2b minus 40. When we add these coefficients, negative 8 and positive 10 gives me positive 2b. The next set, we notice, hopefully you notice in this, that we are multiplying conjugates. So we can apply a shortcut if you want, or you can continue to do FOIL. There's nothing wrong with still doing n times n is n squared, n times negative 7 is negative 7n, 7 times n is 7n, and 7 times negative 7 is negative 49. Your inside and outside are opposites, so they will cancel, and you'll get n squared 40 minus 49. So that's where that shortcut goes, is I don't have to do the outside and inside. I can just focus when I have conjugates on the first times the first and the last times the last. So first times first gives me 4r squared. I know that my outside and my inside are going to be opposites of each other, so I don't have to do that step. And I just have to multiply the lasts, which makes negative 1. So that is where you can save a little time. So here you would have 36a squared minus 16. And so you're only doing those two products. You are cognizant that they are conjugates, that the negative 24a and the positive 24a would cancel. My outside and inside cancel. So number 12 would be 49n squared minus 49. Look at that one. Now we have binomial squares. Again, you don't have to necessarily do FOIL. If you can't remember how to do it, the one thing you do not want to do is distribute this to both of them, and do not, again, do not give me 64a squared plus 49. That is wrong. Do not do that. This is actually equal to 8a plus 7 times quantity 8a plus 7. So your first, and nothing cancels because they're not opposites. So our inside and outside actually are not opposites in this case because they're actually identical. So you would get, you'll notice that the outside and inside are actually the same. So you would multiply it by 2. So let's just do FOIL on this one. First times first gives me 64a squared. Outside gives me 56a. Inside gives me 56a. And then the last gives me 49. So remember how we take that and double it. So my answer is going to be 64a squared plus 112a plus 49. Ooh, that's a big one. So that would be your answer for 13. So how can I do this in a shortcut? Well, remember this format, the template is f squared plus 2fl plus l squared. So you're going to square your first. 3a times 3a gives me 9a squared. Then you're going to do 2FL. 2 times the first times the last. So my first is 3a, my last is negative 2. So 2 times 3a is 6a, times negative 2 gives me negative 12a. And then we're going to square the last. My last is negative 2. Negative 2 times negative 2 gives me positive 4. That would be, that would be the shortcut method. Both ways, don't be afraid to use FOIL. So I know that 15 is going to be 36k squared, and then I have 36k twice is 36 is 72k, and then I'm going to square the last, which is 36. So that would be my answer. I can do that mental math. I'm going to square the first. 3m times 3m is 9m squared. I'm going to multiply 3m times negative 5, which is negative 15, and I'm going to double it. Negative 15m, and I'm going to double it to negative 30m. And then I'm going to square negative 5, which is positive 25. So I can do mental math. I just need to remember the trick. All right, now we're done with the multiplication component. Now we're going to reverse it and we're going to do factoring. So now we want to factor. We want to turn this expression into a product. So the first thing I look at is how many terms are here. There are 2 terms here. So when I think of 2 terms, the first thing I ask, is this the difference of squares? And I look and I say, no, it's not. I know that difference of squares are 2 terms, which this has. That's why I thought difference of squares. But it is subtraction between the 2. And since we don't have subtraction, it is not the difference of squares. So the next thing I have to look is there a common factor? Is there a common factor amongst these 2 terms? In fact, there is. I can take out a 6x. So if I take 6x from 6x cubed, I get x squared. If I take 6x from 6x, I get positive 1. Now notice, I'm left with a binomial again. And I have to ask myself, is this the difference of squares? No, it is not, because it's not subtraction. It is 2 terms. They are both are perfect squares. It's the third one. Sorry, I didn't do that. I stopped after the subtraction. Those are the 3 criteria. So it's not, so I can't factor this any further. So I am done. So that would be my answer. I look at this, 2 terms. This is not subtraction, so I know it's not difference of squares. So I'm looking for a common factor. Common factor would be 3v squared. 3 goes into 12 4 times. V squared goes into v to the 6th, v to the 4th. 3 goes into 15 5 times. V squared goes into v squared. So that would be my answer. Is this difference of squares? No, it is not. So this is my answer. All right, 2 terms, subtraction. However, both not perfect squares. So DOS, no. Common factor, there might be a common factor. Yes, in fact, not only do I have a common factor, but my first term is negative. So when my first term is negative, I have to factor out a negative. So I'm going to factor out a negative 3. So that leaves me with v plus 2. And let's remember how we do this. Remember the prime factorization thing. We're looking for the GCF. Prime factorization of my 2 terms, 3v and negative 6. So that's negative 1 times 3 times v. This is negative 1 times 2 times 3. What do they have in common? They have a negative 1 in common. They have a 3 in common. So my GCF is going to be negative 1 times 3, or negative 3. That's why I took out negative 3. What's left after I take this negative 3 away. I'm left with v. That's where you get this. What's left after you take a negative 3 from negative 6 is 2. That's where I get the positive 2. Okay, so let's look at number 20. First term is negative, so I know I'm going to factor out a negative. I look at the coefficients, negative 4, negative 8. I can take out a 4. I look at the variables. I have x to the 5th, x to the 2nd. I can take out at least 2 from each of those. So x to the 2nd, and that leaves me with x to the 3rd. We're taking 2 from 5. Remember, when we factor or divide, we subtract the exponents. Minus plus 2. Look at that. I was going to do a minus. If I had done a minus here, when I check, a negative times a negative would be a positive. But I don't want a positive. I need that after I redistribute, I need it to be a positive. So this would be my answer. And notice that this is a binomial, but because it's addition, it's not. I can't factor that anymore. I can't factor this one either any further. All right, 2 terms. So we're asking, is it the difference of squares? 2 terms, subtraction, and are both perfect squares. And we get yes, yes, and yes. So I know that this is difference of squares. Difference of squares produce conjugates. Conjugates are identical, yet they have opposite signs. So the way I do that is I take the square root of my first term, which is a. I take the square root of my last term, which is 1, and I'm going to have identical numbers and variables, and I just have to have opposite signs. So square root of k squared would give me k. Square root of 9 would give me 3, so I have k and 3, and I know my signs are going to be opposite because it holds these 3 characteristics. So that's the shortcut for that. 2 terms, subtraction, both perfect squares. So square root of 25 is 5, square root of p squared is p, square root of 16 is 4. So I get 5p plus 4, 5p minus 4. The order doesn't matter. If you put the negative first and then the addition, that's fine, but those signs have to be opposite. 2 terms, subtraction, both perfect squares. So we get 4n minus 3, 4n plus 3. So these can actually be relatively easy, and that's where the efficiency comes into play. And I thought of difference of squares because each of these starting problems have 2 terms. Difference of squares is always going to have 2 terms. This number 25, now this actually has 3 terms. So 3 terms. 3 terms can either be a binomial square, or we're going to do a times c. So which one? Well, we always want to check for binomial square. We know binomial square have 4 characteristics. They have 3 terms, second sign positive. We know the first and the third are perfect squares, and we know that the middle equals 2 times the square root of the first times the square root of the last. So these have 3 terms. Second sign is positive. First and third are perfect squares. And if we take, does our middle, does 2 equal 2 times the square root of b squared times the square root of 1? Sorry, and I didn't do, my middle is 2b. So does 2b equal 2 times b times 1? 2b equal 2b? Yes. So this is a binomial square. So the binomial square is the square root of the first, the square root of the last, quantity squared, and we bring down this sign. So my answer is going to be the quantity b minus 1 quantity squared. So let's take a second and look at this problem. This is b squared minus 2b plus 1. I'm going to sneeze. Excuse me. Let's say we don't see that it's a binomial square. Since it has 3 terms, we can still do a times c. So A is 1, C is 1. 1 times 1 is 1. Factors of 1 are 1. I know that my signs are the same, and they're both negative. So negative, negative, negative 1 makes negative 2. Is this equal to my middle? Yep. So I can continue with my A times C technique. B squared minus B plus 1. All we did was take these and place them into there, right? And this is our A times C method, and now I'm going to factor by grouping. I'm going to group the first two, group the second two. What can I factor out of the first? A B, and I get B minus 1. Notice my first term is negative, so I have to factor out a negative 1, and I get B minus 1. I know I did it correctly because these two are the same, so we get B minus 1 times B minus 1, which could be written as the quantity B minus 1 squared. So same answer as that. It's just we solved it through A times C. But there is benefits of recognizing when they are binomial squares. So let's look at 26. 3 terms. Second sign positive. First and third are perfect squares. Square root times 2 equal my middle. Yep, 2 times p times 3 is 6p. So I know that this is a binomial square. I'm going to take the square root of the first. I'm going to take the square root of the last. And then I'm going to bring down the sign of the first. And I get the quantity p plus 3 squared. Let's look at this. This gets a little bit more intimidating, but it's 3 terms. So I should always test for binomial square. Second sign positive. Perfect square, perfect square. Square root times 2. Does that equal my middle? Oh yeah, it does. So I'm going to take the square root of the first, square root of the last, and I'm going to pull down that sign of the first. So 5x plus 1 quantity squared. 3 terms, second sign positive, perfect square, square root times 2 gives me 20x. So square root of 16x squared is 4x, square root of 25 is 5, and I'm going to bring down this sign. That sign goes there, and we go. All right, 3 terms, second sign positive, however, not perfect square. So this is not a binomial square. So we have to go now to A times C. A is 1, C is 15. 1 times 15, factors of 15 are 1 and 15, 3 and 5. Signs are the same. When this is a positive, we know that that means it's the same. And then we look here to find out that they're both positives. So we put those signs in our factor pairs. 1 plus 15 is 16, 3 plus 5 is 8. Which one is equal to my middle value? The 8. So I'm going to rewrite these, and I'm going to turn this 3 terms into 4 terms. So we get m squared plus 3m plus 5m plus 15. Remember, all we did was change the 8m to 3m plus 5m, because 3m plus 5m equals 8m. We didn't change the equation, we just broke it into 4 terms. And then our first came down and our last came down. So we didn't really do anything. Now we are going to group in pairs. So we look at that first term, m squared plus 3m. We can factor out an m, you get m plus 3. We look at the second terms, 5m and 15m. We can factor out a 5, and we get m plus 3. We know we did it right because these are the same. We're going to pull that m plus 3 out, and we're going to be left with m plus 5. So notice that we took the m plus 3 out, and you notice what's left, m plus 5. That's how we got that term. All right, 3 terms, second sign positive, but not a perfect square, so we know it's not a binomial square. So we are going to do a times c. A is 1, c is 45, equals 45. Factors of 45 are 1 and 45. 2 no, 3 and 15, 4 no, 5 and 9, 6 no, 7, 8, and we're back to 9. We know my signs are the same, and this time they're both negative. So negative, 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 negative. Negative 46, negative 18, and negative 14. These are equal to my middle. So this equation now becomes x squared minus 5x minus 9x plus 45. We're going to group. You're going to factor out an x. You get x minus 5. We're going to factor out a negative 9. Recognize that my first term is negative, so I have to factor out a negative. When it's positive, we factor out a positive. When it's negative, we factor out a negative. That leaves me with x minus 5. So my answer ends up being x minus 5, x minus 9. Number 31, 3 terms. Second sign is negative, so it's definitely not a binomial square. So let's do a times c. A is 1, c is negative 30, so this gives me negative 30. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4, no, 5 and 6. Signs are different. So when that is a negative, we know my signs are going to be different. And I look here and I know that the bigger is negative. So we have 1 and 30. 30 is more than 1, so the bigger of these two gets the negative. And the other one's going to get positive because I know that those signs have to be different. One's going to be positive, one's going to be negative. So bigger number gets the negative, positive gets the smaller. Bigger gets the negative, bigger gets the negative. This gives me negative 29, negative 13, negative 7, negative 1, which equals my middle, that one. So this becomes m squared plus 3m minus 10m minus 30. Let's group them. And we can factor out an m plus 3. We're going to factor out a negative 10, m plus 3. And that gives me m plus 3 times the quantity m minus 10. Again, let's look at this. 3 terms, but subtraction. So I'm going to use a times c. A is 1, c is negative 60. Factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Woo, that's a lot of factors. Signs are different, and this time bigger gets the positive. So positive gets, or the bigger gets the positive this time, and the smaller gets the negative. So bigger positive, smaller negative. That gives me 59. This gives me 28. This gives me 17. This gives me 11. This gives me 7. And this gives me 4. Which one's equal to my middle? My middle is 4, so I got negative 6 plus 10. So we get x squared minus 6x plus 10x minus 60. I'm going to group them. I'm going to factor out an x, and that gives me x minus 6. I'm going to factor out a 10, and that gives me x minus 6. I'm going to pull out the x minus 6, and that leaves me with x plus 10. That's a horrible 6. Minus 6. Minus 6. Good. All right. Let me just stop this for a second. Good. All right. So, ooh, look at this one. 3 terms, subtraction. So not a binomial square, but something we should notice is that I have an a now. So when I do a times c, I'm going to multiply 3 times negative 6. That's my a and c. So that gives me negative 18. Factors of 18 are 1 and 18, 2 and 9, 3 and 6, 4 no, 5 no. Signs are different. When this is a negative, it's different. When this sign is a positive, that means they're the same. So this is a negative, so I know the signs are different, and then I look here to see that the bigger is going to get that sign. So the bigger is the positive. So the bigger of these two numbers, of these two numbers, of those two numbers. Oh, isn't that interesting? That was there. And since the signs are different, one's going to be positive, one's going to be negative. That gives me 17. That gives me 7. That gives me 3. These are equal to my middle. So I have 3n squared minus 2n plus 9n minus 6. I get the negative 2 and the positive 9 from right here. Now I'm going to group first 2, second 2. I'm going to factor out just an n. That's all they have. They don't have a coefficient in common, 3 and negative 2. So I can just take out an n. That gives me 3n minus 2. I have 9n and negative 6. I can take out a 3, and that leaves me with 3n minus 2. I know I did it right because they're both 3n minus 2 in the parentheses. I'm going to take that away, and that leaves me with n plus 3. Let's look at 34. So a times c, 2 times negative 9 gives me negative 18. 1 and 18, 2 and 9, 3 and 6. Signs are different, and bigger gets the negative. So this time, the bigger of the two gets the negative, and the smallers get the positive. Negative 17, negative 7, negative 3. This time, my terms are 1 and negative 18. So 2a squared plus a minus 18a minus 9. Group them. Let's move this up a little bit. I'm going to factor out an a. That gives me 2a plus 1. I'm going to factor out a negative 9, which gives me 2a plus 1. 2a plus 1, a minus 9. Ooh! Look at this. This one gives me a little bit of, is this the difference of squares? 2 terms, subtraction. Oh, almost. This is a perfect square, but that is not a perfect square. So I cannot factor this any further. So this is the answer. But I have to be aware of those situations where I might be able to factor after I've factored. All right, so let's do a times c, 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Signs are the same, and they're both positive. So I get 25, I get 14, I get 11, and I get 10. So this becomes 8x squared plus 4x plus 6x plus 3. I'm going to factor out a 4x. That gives me 2x plus 1. I'm going to factor out a 3. And that gives me 2x plus 1. So my answer is 2x plus 1, 4x plus 3. You can do it that fast. You've done enough problems and you are ready for the assessment. So there is your measure. I see that these are perfect squares. I see that there are 3 terms, and I see that the second sign, is this a binomial square? So I take the square root. I take the square root and times by 2. 2 times 3a is 6a times 2 is 12a. Oh, it is not a binomial square. Really close though. That's a really good example. So I just got to go back to a times c, which is 9 times 4, which equals 36. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, no, 6 and 6. Signs are the same, and they're both negative. Negative, 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 negative. So I get negative 37, negative 20, negative 15, negative 13, negative 12. So negative 2 and negative 18. So I make this 9a squared minus 2a minus 18a plus, I think it was 4. I'm going to group. I'm going to factor out an a, only an a. That gives me 9a minus 2. I'm going to factor out, I can't factor out a 4. I got to just, negative 2. Just a negative 2 from those two terms. That leaves me with 9a minus 2. So my answer is going to be 9a minus 2 times the quantity a minus 2. I like that one. That was one of the better ones. If you can get that right, you're looking pretty good. All right, 4 terms. So when we see 4 terms, we need to, is it factor by grouping? We're going to group the 2. So I can factor out a 2x squared, which gives me 6x plus 7. These don't have a common factor, so I'm going to have to factor out a 1. And that gives me 6x plus 7. I did it right because what's in the binomials and the parentheses are the same, and that leaves me with a 2x squared plus 1. Neither of those can be factored any further, so this is my answer. Let's factor these 2 and these 2. Again, I'm going to look 30 and 48. Ooh. 6 goes into those. 6x squared. 6 goes 5x. 6 times 8 is 48. 5x and 8 have no common factor, so I'm going to factor out a 1. Let's say I didn't see the 6. Let's say I only saw the 3. You would notice that you didn't factor the GCF because these wouldn't be the same. This would be 10x plus 16. So remember, you always should revert back to making sure those parentheses are the same. So this will give you 5x plus 8, 6x squared plus 1. Last 2. So we can factor out an r squared. We get 3r plus 4. We can factor out a negative 4? No, 4. Negative 8. Ooh, I like that. And I thought about 4, but if I do that, I would have gotten a 6 here, and that's not the same as 3. So that's also how I can sort of cheat and see what that's going to be. So that gives me 3r plus 4. So 3r plus 4, r squared minus 8. Ooh, difference of squares, 2 terms, subtraction, both not a perfect square, not DOS. So that would be my answer. And last but not least, you can factor out a v squared. You get v plus 5. You can factor out a negative 4. You get v plus 5. V plus 5 times the quantity v squared minus 4. Is this difference of squares? 2 terms, subtraction, both perfect squares? Yes. So I can factor this again. So I get v plus 5, and then the v squared minus 4 is the difference of squares, so I'm going to produce conjugates. Take the square root of first, take the square root of last, and then give opposite signs. So that would be your answer for number 40. Woo! That was a lot of problems. But hopefully you're ready, and come and see me if you have questions.